Let us try to trace the curve r equal to a cos 2 theta. R equal to cos 2 theta is a rose curve. So let us give it r equal to a cos 2 theta as equation number 1. We take the following points to trace this rose curve. The point number 1 is about the symmetry. So since we know that it has no symmetry about the pole because the value of power of r is always odd. So we have the first symmetry about the initial line. How to check that the curve is symmetric about the initial line? We have to just replace theta by minus theta. So we know that cos of minus theta is cos theta. So the curve equation of curve doesn't change, hence this curve is symmetric about the initial line. Since the equation to the curve remains unchanged by changing theta to minus theta, so the given curve is symmetric about the initial line theta equal to 0. Similarly, the second point about the line perpendicular to the initial line through the pole, that is line theta equal to pi by 2. Again, just look here. If we replace r by minus r and theta by minus theta, the equation will be changed. Okay, so now we are not able to check the symmetry about the line theta equal to pi by 2 using the first condition. But if we replace theta by minus theta, so cos 2 theta, just look here, the given curve is symmetric about, if we replace theta by minus theta, so cos 2 pi minus 2 theta is cos 2 theta. So again, the equation of curve will not change. Hence, this curve is symmetric about the initial line theta equal to 0 as well as the line theta equal to pi by 2. Second thing about the pole, for theta equal to pi by 4, r equal to 0. So the curve passes through the pole. What is the tangent at pole? So tangent at pole is given by r equal to 0, which implies a cos 2 theta equal to 0, which means cos 2 theta equal to 0 r 2 theta equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, and so on. So what is the value of theta? Theta equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. We won't take 9 pi by 4 because as we know that sine and cosine and periodic function of period 2 pi. So the 9 pi by 4 is 9 pi by 4 is like nothing but 2 pi plus pi by 4. So this will be repeating the first part, this one. So we have only 4 tangent at pole, pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Now loops, since here n equal to 2 is even, so the number of loops is 2n, which is equal to 2 into 2, which is equal to 4. And now how to check that where these loops are lying between? So the first loop lies between 7 pi by 4 to pi by 4. Second loop lies between pi by 4 and 3 pi by 4. Third loop lies between 3 pi by 4 to pi by 5 pi by 4. And the last loop will lie between 5 pi by 4 to 7 pi by 4. Right? How to check that it loops like? So we will draw that at that time we discuss about that. Now let us see the angle between the radius vector and then tangent. So differentiating one with respect to means r equal to a cos 2 theta with respect to theta, we have dr d theta equal to minus 2a sine 2 theta. Okay, and which is this is dr d theta. So let us reverse this. D theta dr equal to 1 upon minus a sine 2 theta. And if you multiply by r d theta dr is r upon minus a sine 2 theta. The value of r equal to a cos 2 theta. A will cancel, so minus cos 2 theta, which gives us tan phi is equal to minus cos 2 theta, or minus cos 2 theta can be written as tan pi by 2 plus 2 theta. So phi is equal to pi by 2 plus 2 theta is the tangent at any point of the given curve. Table values. Let us draw some table values. For example, if theta equal to 0, theta equal to 0, r equal to a, because cos 0 is 1, and theta equal to 0, then phi is equal to pi by 2. If theta equal to pi by 4, cos pi by 4 is cos pi by 4 into 2, which is cos pi by 2. Cos pi by 2 is 0, so the value of r is 0. And here if you put pi by 2, so pi by 2 plus pi by 2 into pi by 4, which is pi by 2 plus pi by 2 is nothing but pi. The next thing is if you put theta equal to pi by 2, then cos pi is minus 1. It is negative of minus a, and the phi is equal to 3 pi by 2. Now, let us draw about the reason of absence. Since the value of cos 2 theta lies between minus 1 to plus 1, so the whole curve lies within the circle of radius a. If theta increases from 0 to pi by 4, then r decreases from a to 0. When theta equal to pi by 2, then the value of r is minus a. It means that the value of r is positive in the opposite direction. That is, for theta equal to 3 pi by 2, since the curve is symmetric about the initial line and the line theta equal to pi by 2, so we trace the curve in first quadrant, then the remaining curve can be traced by symmetry as shown in the figure. Okay, let us try to trace this curve. The first point, what are this curve passes through pole? Yes, the curve passes through pole. What is the tangent at pole? So first tangent is line theta equal to pi by 4. First we have to draw theta equal to 0, theta equal to pi by 2, theta equal to pi, and theta equal to 3 pi by 2. Right. Second thing, tangent at pole is, this is the first tangent, this is the second tangent, this is the third tangent, and this is the fourth tangent. And since this is the point, what is this point? It is a0. This is 0a, means what we can say that this is against, because it will come minus, so this is a. So we are getting 4 different points over here. Okay, this is tangent. For example, this, what is the tangent at this point? This is tangent at this point. This is tangent at this point. This is tangent at this point. Okay, so how to get the first loop? This is the first loop. This is tangent. This is tangent. Since the curve is symmetric about initial line, so if we draw only the first part, we are able to draw the second part. Right? The curve is symmetric about the initial line again. This is the first part. Similarly, theta equal to pi by 4 to theta equal to 3 pi by 4, we have another loop. This is tangent. This is tangent. We get another loop. So curve is symmetric about the line theta equal to pi by 2. So if we are getting this one, we are able to get this one also. Right? And again, since this is symmetric about this, so same thing we will get over there. Since this is symmetric about the initial line theta equal to 0, so what is above we are getting, we get the same in the below the initial line theta equal to 0. So this is the approximate shape of the given rose curve. Thank you.